Today I'm going to do LeetCode question 704, binary search. So given an array of integers nums, which is sorted in ascending order, and an integer target, write a function to search target in nums. If target exists, then return its index, otherwise return -1. And you might write an algorithm that with O of n runtime complexity. Okay. So yeah, for example here, target 9 exists as position 0, 1, 2, 3, 4, so we return 4. Of course, the easiest way is to iterate through the array, which will take O of n time, and find if 9 exists. But unfortunately, we can't do that because that takes O of n time, and this question specifically asks for O of log n time. Okay, so O of log n, whenever you see log n, it's a very good indicator that it means we need to divide the problem. We need to do divide and conquer. Okay, we need to divide the problem in half. Okay, and this is kind of easy to do with this example because array is sorted in ascending order. So what do I mean by that? Okay, so I'll just rewrite the array here. -1, 0, 3, 5, 9, 12. Okay, and we're looking for 9. So what does that mean? So we want to start from the middle. Okay, so how do we calculate the middle? We do left, or the very left plus the very right, all divided by 2. So 0 plus 0, 1, 2, 3, 4, 5 over 2, which is equal to 2. If we get the integer version, round down. So 0, 1, 2. So we look at this guy here. So is this equal to 9? No, it is not. So where else can 9 be? How can we divide this problem? So this array is in sorted order, right? And we see that this is not 9, but this is smaller than 9. So what does that mean? We want to look for bigger numbers, and that means we want to look to the left of 3. So this is where the dividing comes in. So what we do is move this pointer here and just look at subdivide array and look at this portion here, and again find the average or find the median and search there. So 0, 1, 2, 3, so 3 plus 5 over 2 is 4. Okay, 0, 1, 2, 3, 4, and turns out we found it. Okay, great. So that's how we get it in O of log n complexity, by dividing and conquering the problem, by dividing the problem in half. Okay, and what about this case where target is equal to 2? Okay, so I'll do that here. So what if our target is now 2? Okay, again we start from the two ends and look for the middle, and so we start searching from the middle. So it's this guy, and we want 2. So it turns out 2 is smaller than 3. So the zone we have to look at now is to the left of 3. Okay, so we look at here. Okay, and our right pointer is now here. Okay, and what is the median of this? So 0 plus 1 over 2 equals 0. Okay, this is not -2, so, and this is actually smaller than -2, so we want to search to the left of this. Okay, so now, okay, and we find the median here, which is 1 plus 1 over 2, which equals obviously 1. This is not 2, and it is still smaller than 2, so we have to search to the right of it. Yeah, sorry, I meant to the right. To the right of it. Okay, so we move our left pointer here. Okay, but now our right pointer is here, and our left pointer is here, and the position of right is less than the position of left, which means this can't happen, okay? The right pointer cannot be smaller than the left pointer, so that means basically this element doesn't exist, and we return -1. And this is O of log n runtime complexity with O of 1 space complexity constant times space. Okay, now to code this up here, I want to initialize my left and right pointers at the appropriate indexes. -1, okay. And then have a while loop here, while left is less than right. So we don't want left to pass right, okay? Other than, because then that means our target doesn't exist. Okay, left should always be the left of our range, and right should always stay at the right of our range. So while left is less than right, I'm going to calculate the median index. Left plus right over 2. Okay, and if nums at median index is equal to target, then return median index. Okay, else if nums median is less than target. Okay, so if we're at position 3 here and we want to search for 9, then we search this range now. So we want to move our left index, which was originally here, to here. So then our left index becomes originally left index here, right index here. So then our left index becomes here and our right index here. Okay. So we want to do is left equals median plus 1. Else, if at index median it's greater than target, we want to reduce our scope to the right of nums at index median. So right equals median -1. Okay. Else, if after all this, this condition fails and we exit out of the while loop, then the element doesn't exist and we return -1. Okay. Now let's run the code. Okay, that works, and I'll try with the other examples. Okay, and finally I'll submit. Let's see what could be wrong here. 0, 0, 1, 0. Nums median, yeah, that's right. Run nums -1. Oh, well, left is less than or equal to right. Okay, sorry. I want to, even if left and right are at the same position, I want the code just to check. Okay, there you go. Great, thanks for watching.